Hi everyone and welcome back to my channel. On this series we've been talking about functions, and today we'll be looking about the domain and range of functions. Meanwhile, if you haven't subscribed to my channel yet, tap on the subscribe button. It's totally free. So I started talking about the domain and range of functions. From the first video I gave a brief introduction, so let me just recap a little bit. So for a function, let's call it f of x, and let's say that f of x is equals 3x. If x is 5, it means that 3x is 15, and this is a output and this is a input. Now for every function, every possible number that could be an output is called a domain. For this function, f of x equals 3x, every possible number you can think of will surely give us an output. Minus 1000 would give us minus 3000. Every number you think of would surely give us an output. So the list of all possible input values is called domain. Possible input. And for your output, the list of all possible outputs given the inputs, right? Given the possible inputs is called range. This is called range. So that's what we'll be talking about today, and we'll be drawing examples from different kinds of functions. So clearly for this function here, because every kind of input would give us a defined output, will give us an output, we can say that the domain of this function, the domain is from minus infinity to infinity, and our range, because as outputs we can get every number, any number we can think about, you can say our output is also from minus infinity to infinity. So let's look at a rather more complex example. So let's say we have f of x equals x squared over x minus 3. So when we have a rational function, that's a function that has a denominator, we always remember that any number at all, say x over 0, is going to be undefined. So we want our domain to include all possible values, right, except the value at which this function is undefined. So for this, when our x is equals 3, we would have whatever x squared is over 0, which will make this function undefined. So it means that for our domain, we don't want x to be 3. X should not be equals 3. So when you're asked about the domain of this function, you can either say x is not equals 3, or more appropriately, you can write it as an interval, where you simply say that the domain is from minus infinity to 3 with the parenthesis union 3 to infinity. Like I said in the first video, when you have a square bracket, it means 3 is part of the interval. But when you have a parenthesis instead, it means all values from minus infinity. In this case, it means all values from minus infinity to just before 3. That means it's going to include numbers like 2.9, 2.99, 2.99999, but it doesn't include 3. For this interval, It includes numbers from 3.0001, 3.1, 3.2. They are all here, but 3 is not included in this interval. I hope that makes sense. So let's look at another function. So we have x. Let's look at this other function. Let's look at this function. Here we have x. This is going to be a quadratic function where we are going to have, let's say, x minus 3. Let's say our f of x is x minus 3 all over x squared minus 5x plus 6. So how do we figure out the domain for this function? Remember, like I said here, we don't want 0 in the denominator. So we are going to have to find the zeros of this denominator. Because the denominator is a quadratic equation, we're going to have to find its zeros. So hopefully it's something you can do. If not, let's just hurry through it. So you have x squared minus, that's a minus, x squared minus 5x plus 6. To solve this, we want to find its zeros. To solve this quadratically, there are many methods, but let's use the factorization method. So the first thing you do is you multiply the constant term, which is 6, times the coefficient of the first term, which is 1. So that gives us 6 times 1 equals 6. So now we want to find the factors of 6 whose sum will give us minus 5. We want to find the factors of 6 whose sum will give us minus 5. So factors of 6, you have 2 times 3, you have minus 2 times minus 3, you have 6 times 1, you have 1 times 6, and so on. So which of these factors, which of the combination of these factors will give us minus 5? That will be this. So it means for this expression, we are going to have x minus 2. So we're going to be replacing minus 5 with this. So you have x minus 2, x squared minus 2x minus 3x plus 6. I hope this makes sense. So you have minus 2x minus 3x would still give you minus 5x. So let's just wipe this. Okay. And all this equals 0. So you try factorizing now. You have, for these two terms, you have x. A common factor is x, and that leaves us with x minus 2. And for these two terms, you have your common factor as you can use minus 3. And when minus 3 divides this, you have x. Then you have minus 2 equals 0. So that means you have x minus 2 and x minus 3 equals 0. So that means that our x is either equals x, you can say x minus 2 equals 0, or x minus 3 equals 0. So that would mean that our x would be equals 2 or 3. So to check whether this is correct, if you substitute either 2 or 3 into this equation, you must get 0. So you have, let's use 2. 2, for example, 2 squared is 4, minus 5 times 2, that's 4 minus 10, that's minus 6. Minus 6 plus 6, that's 0. So you can try out 3 by yourself. So this would give us, let's wipe this for space. So that means since our x is equals 2 or 3, it means here our domain would be, this also means that at 2 or 3, when x is at 2 or 3, this expression is undefined. So we don't want 2 or 3 in our domain. That's very important. So for this, for our domain, we are going to have from minus infinity to 2 union 2 to 3 union 3 to infinity. So that's our domain. And I hope this makes sense to you, because numbers between 2 or 3, like 2.5, we would define this function. So that's why you would have to include the interval between 2 and 3. So this next one would be for you. Try this out. So you have, let's say, x minus 5 all over x squared minus 12x plus 3, 5. Take out 2 minutes, see if you can do it, and let's move on to the next question. So the next thing I want us to consider is functions that look like this. You have f of x equals square root of x minus 5. So what's the domain? What's our domain? This is a square root function. What's our domain? So for this function, the square root function, we want numbers for x that would give us a root of from 0 and above. We want numbers that will give us a root of from 0 and above, because square root of 0 is 0, 1 is 1. So we want something that would give us this and above. So let's see. So that means that x here, the domain would be, since we are concentrating on real numbers, we can say that our domain here would be x greater than or equals 5. You can also write this as an interval. Because 5 is part of this interval, we are going to use a square bracket. So you have from 5 to infinity. From 5 to infinity. Okay. So since we have from 5 to infinity as our domain, our range also, if you observe, when we use 5, we have 0. So our range is going to be from 0 to infinity. Let me repeat what I said. When you have input as 5 here, 5 minus 5 is 0. Root of 0 is 0. So it means that our range is going to be from 0 to infinity. And I hope this makes sense. So how about you try this, where f of x is equals 9 plus x. What do you think the domain should be? If your answer is from minus 9 to infinity as domain, then you are absolutely correct. So let's move on a little bit. Like I said, for the domain, for this, if your answer is from minus 9 to infinity, then you are correct. So let's look at this. I've just shown you how to solve questions like this, and I want you to take out just 2 minutes of your time to see whether you can figure this out. If you need to solve this the quadratics for gx, please feel free to replay the video. So for more examples, this question looked very, very interesting to me. So we're going to find the domain and the range of linear functions that model real-world situations. So we're going to read the question, then find out what should be in the domain or and range. So a construction crew is lengthening a road. Let L be the total length of the road in miles. Let D be the number of days the crew has walked. Suppose that L equals 4D plus 200. Gives L as the function of D. Yeah? The crew can walk for at most 80 days. The crew can walk for at most 80 days. Okay, so now for our domain, we want to choose the number of days the crew has worked. And since the crew can work at most 80 days, at most 80 days means they can't work past 80 days. So remember this is the formula that gives the relationship between the days of work, that's D, and the length of the road. So if they can work at most 80 days, it means that our domain, which is the days, right, is going to be from 0 days. Domain is going to be from 0 days to 80 days. And that's because 0 is part of this domain, because for 0 as a number of days, you still have a value for L, that's 200. So then for the range is the length of the road. So this goes from the result you have when D is 0 to the result you have when D is 80. So when D is 0, you have, just like I said, 200. And when D is 80, you have 80 times 4, that's 320, plus 200, that's 520. So it means our range would go from 200 to 520. I thought this was really interesting. So let's look at the second question. So for this question, we want to, a sugar sweet company delivers sugar to its customers. Let C be the total cost to transport the sugars in dollars. Let S be the amount of sugars transported in tons. The company can transport up to 20 tons of sugar. Suppose that C is equals 120S plus 1,500. So now we want to find what's the amount of sugar transported in tons. So the company can transport, this is the answer, the company can transport up to 20 tons. They can't transport more than 20 tons. So that means our domain will go from 0 to 20, right? And what's our range? Our range will be the cost of the transportation. And this is the formula for the cost. So this range will hold the cost from 0 to 20. So when it's 0, you have 1,500, and when it's 20, you have 120 times 20 plus 1,500, which gives us about 3,900. So that's that. So let's move on to the next question. We want to find the domain and range from the graph of a continuous function. Now this is very interesting. So looking at this graph, there's something I need you to notice. In the first video of this series, I talked about drawing on a number line. I talked about representing inequalities, and then I remember saying that if x is greater than, let's say, 0, this would be this. But once x is greater than, let's say x is greater than or equals 4, this is shaded. So that's the same idea we're going to be using here. So where you have this open circle, it means that the value at that point is not in the interval, just like x greater than 0. X greater than 0 goes from 0.1 and above. X is not included. X greater than or equals 4 means x can be 4. So that's why this is shaded. So for the domain of this, it goes from -3 where minus 3 is included. As you can see, there is a square bracket here to 3, but there is a parenthesis here because 3 is not included because this circle is open. And for the range is the corresponding y value at this domain value. So for minus 3 you have 5, and for 3, let's see, you have 5. For 3 too you have 5. But then here you see the graph, it depresses up to at 0, at x equals 0, you have minus 4. So it means our graph on the y-axis spans from minus 4 to 5, minus 4 to 5. And because 5 is for minus 3, right? For minus 3, 5 is in the interval, so that's why you have a square bracket down there. I hope this makes sense. So with that, can you try this? So for this case, we are not finding the inputs. We want to find the domain and the range. What do you think? What's the domain of this graph? And what's the range of this graph? So a hint, you'd notice that this graph is continuous down here. It's continuous. What does that tell you about the range? Okay, let's look at this. This is just like the first one we looked at. So take out 2 minutes and see if you can figure this out. If there are questions, let me know in the comment section. And remember to subscribe, share the video with your friends, and I'll see you on the next one, where we would be talking about, let's see, local maxima and local minima of a function. Bye.